You know the sound exactly. Your dog circles their bed, dramatically collapses, and lets out a long, heavy huff. It sounds like they just finished working a brutal 40-hour shift. They look at you, eyes half closed, and deliver that deep, exhausted sigh. It is funny. It is cute. It feels incredibly human. Most people assume this is a sign of passive-aggressive disappointment. You didn't take them for that extra walk. You didn't share your dinner. So they sigh. Like a frustrated roommate paying too much rent. We project our own emotions onto them. We assume they are experiencing complex human resentment or even chronic canine depression. But behavioral neuroscience tells a completely different story. That funny little huff? It is not an emotional complaint. It is a highly evolved, observable marker of a mammalian nervous system reset. To understand the sigh, you have to understand the biological engine inside your dog. When a dog anticipates an event, a walk, a thrown ball, a piece of food falling from the counter, their sympathetic nervous system activates. This is the biological gas pedal. Heart rate elevates. Cortisol and adrenaline trickle into the bloodstream. Respiration becomes shallow and rapid to prepare for explosive movement. This is called tachypnea. But what happens when the anticipated event does not occur? The walk is over. The food is eaten. The biological engine is still revving, but there is nowhere to go. They do not experience resentment. Instead, their biology must process a rapid arousal downshift. They have to clear those circulating catecholamines. They must transition back to the parasympathetic nervous system, the rest and digest state. And to do that, they deploy a mechanical switch. Enter the physiological sigh. This long, deep exhalation forcefully reinflates collapsing alveoli, the tiny balloon-like air sacs inside their lungs. But it does not just fix their breathing. It directly stimulates the vagus nerve. Vagal stimulation acts as a neurological brake. It immediately drops the heart rate and initiates total physical relaxation. The sigh is not a complaint. It is the exact mechanical sound of a dog turning off its internal engine. Because this isn't just psychology, it's chemistry. And this chemistry is controlled by a deeply hidden network in the brainstem called the pre-Botzinger complex. Within this network lies a tiny subpopulation of neurons. Their only job? Initiating sighs. They act in perfect tandem with the vagus nerve to synchronize heart rate variability with respiratory sinus arrhythmia. How do we know this isn't just a conscious emotional choice? Because researchers at Stanford University and the UCLA David Geffen School of Medicine mapped the exact circuit. In a groundbreaking 2016 study published in Nature, scientists identified two specific neuropeptides, neuromedin B and gastrin-releasing peptide. These peptides are produced by roughly 400 tiny neurons in the brainstem. When released, they act on the pre-Botzinger complex to override normal breathing. They force the lungs to convert a standard breath into a double-volume physiological sigh. Statistically, when researchers blocked these exact receptors, sighing reduced to 0%. The dog has no choice in the matter. The sigh is a hardwired, chemically induced autonomic reset. It is a mandatory biological function. The timing of this chemical release is spectacularly precise. A 2008 telemetry study from the Department of Ethology at Eötvös Loránd University in Hungary proved exactly when this happens. Using non-invasive monitors, researchers tracked heart rate variability in family dogs across different environments. The exact findings? They discovered a statistically significant increase in vagal tone the second dogs transitioned from an alert standing state to a resting state. And the acoustic marker of this sudden autonomic transition? The deep, resonant sigh. It is the sound of the sympathetic drive flatlining. It is the biological equivalent of slamming a heavy door shut on stress. But why is it so loud? Why did a hidden physiological mechanic evolve to become so highly audible in domesticated dogs? To answer that, we have to look back at the ancestral gray wolf. In the wild, survival depends on hypervigilance. Hunting, patrolling, and threat assessment require the entire pack to be locked into sympathetic arousal. But they cannot sustain that state forever. Caloric energy is precious. When the biological need for vigilance ends, say upon returning to the den, the pack must transition to rest. But in dense brush or absolute darkness, visual cues are useless. A relaxed tail cannot be seen. So the audible sigh evolved as a termination signal. Rooted in the ethological concepts of Konrad Lorenz, this sound is an acoustic broadcast to the entire pack. It communicates one distinct message. Action patterns are terminated. I am dropping my guard, and you can too. As wolves evolved into the domestic dogs sleeping on our couches, this acoustic signal was heavily selected for. Look at the famous Bonn Oberkassel dog burial in Germany. Dating back over 14,200 years, it is the earliest undisputed evidence of a dog buried affectionately with humans. Early humans needed companions that could read and integrate into complex, dangerous social structures. The acoustic settling sigh was preserved because it served as the ultimate cross-species communication tool. It signaled docility. It signaled profound relaxation. It prevented aggressive misunderstandings in fire-lit caves. Over millennia, dogs were selectively bred to broadcast their parasympathetic resting state directly to us. And modern genetics finally reveals exactly how deep this connection goes. A 2017 genome-wide association study out of Princeton University, published in Science Advances, unlocked the code. Researchers identified specific transposon insertions in the canine genome, specifically affecting the genes GTF2I and GTF2IRD1. In humans, mutations in this same region cause Williams-Buren syndrome, a condition characterized by extreme hypersociability. These exact genetic insertions drive the modern dog's desperate need to seek proximity to humans. They are genetically bound to co-regulate their nervous systems with ours. The deep sigh your dog emits at your feet is a direct, downstream, phenotypic result of these mutations. They don't just want to relax. They are genetically hardwired to sync their parasympathetic resting state exclusively with your presence. When your dog sighs and settles next to you, it triggers a massive neurochemical cascade for both of you. A landmark 2015 study from Azabu University, published in Science, observed this interaction. Dogs engaging in relaxed, proximity-based affiliative behaviors with their owners experienced a massive spike in urinary oxytocin levels. We are talking about a 300% increase. The heavy sigh often precedes the establishment of this oxytocin loop. It marks the precise second your dog abandons environmental vigilance and surrenders to affiliative relaxation. When they sigh, they are bathing their brain in the bonding hormone. It is not disappointment. It is the sound of absolute, unconditional biochemical trust. Because the physiological sigh is a deeply hardwired marker of autonomic health, we must pay close attention to it. This brings us to the vital clinical warning. A change in this settling behavior is not just a quirk of aging. The sudden cessation or acoustic alteration of this sigh is a primary clinical red flag. If your dog stops sighing to settle, or if that long, smooth exhalation suddenly shifts into a stuttered grunt, a groan, or a whine, it means the system is breaking down. It indicates an absolute inability to access the parasympathetic nervous system. The dog is trapped in a state of sympathetic hyperarousal due to hidden physical pathology. And as a pet owner, you are the first line of defense in catching it. The first hidden pathology is musculoskeletal pain and osteoarthritis. A healthy sigh occurs exactly as the dog's weight fully transfers to the floor. If that sigh turns into a short, clipped groan, it almost always points to spinal stiffness or joint pain. When lying down causes acute physical pain, the vagus nerve's relaxing effect is instantly hijacked. The brain experiences a sudden spike in pain-induced cortisol. A 2006 study out of the University of Glasgow proved this link. Researchers demonstrated how unvoiced or altered resting behaviors correlate directly with chronic pain scores in dogs suffering from osteoarthritis. If the settling sigh sounds forced or painful, the dog is not relaxing. They are bracing for impact. The second red flag is canine cognitive dysfunction, often referred to as dog dementia. If an elderly dog begins pacing endlessly and the settling sigh disappears entirely, it is a hallmark sign of neurological decay. The brainstem's ability to regulate sleep-wake cycles physically degenerates. The dog is stripped of the ability to execute the physiological sigh and downregulate. A 2013 longitudinal study from the University of Copenhagen found that disrupted sleep-wake cycles and severe restlessness were present in over 60% of dogs diagnosed with CCD. The disappearance of the sigh signals a total collapse of the autonomic transition mechanisms. Their brain literally forgets how to turn the engine off. The final red flag involves cardiopulmonary distress. Remember, a healthy sigh requires unimpeded alveolar reinflation. It should sound airy and effortless. If a sigh sounds wet, raspy, or requires extreme abdominal effort to execute, it points straight to respiratory compromise. Research from the Seattle Children's Research Institute in 2014 detailed how changes in sigh frequency and acoustic profiles are early clinical biomarkers for severe conditions. A wet, strained sigh can indicate pulmonary edema, laryngeal paralysis, or even early-stage congestive heart failure. The sigh is a diagnostic tool. If the sound changes, the biology has changed. Never ignore a broken sigh. So the next time your dog circles their bed, drops their chin onto their paws, and lets out that dramatic, exhausted roommate huff, listen closely. Do not project human resentment onto them. Do not assume they are complaining about a lack of treats. You are witnessing a 14,000-year-old evolutionary broadcast. You are hearing the mechanical engagement of the vagus nerve. You are listening to the exact moment adrenaline is cleared from the bloodstream, replaced by a surge of bonding oxytocin. It is a masterpiece of mammalian biology, governed by ancient brainstem circuits and hardwired genetics. They sigh because the hunt is over. The patrol is finished. The territory is secure. They sigh because they are finally allowing their sympathetic nervous system to go offline. And they do it loudly, right at your feet, because their genetics tell them that you are the safest place in the world to be vulnerable. What does your dog's deep sigh sound like? Let me know in the comments below. And if you think the science of canine sighing is mind-blowing, just wait until our next video. We are breaking down the exact neurological reason dogs circle 3 times before lying down, and the ancient survival-based biology behind it is even stranger than you'd expect. Subscribe, and I'll see you there.